By now, you probably already heard of ChatGPT and all the amazing things it can do, from writing essays to answering complex questions to even writing code. It is by far the fastest growing app in history, reaching 1 million users in 5 days and 100 million in 2 months. But even with all the buzz around it, in trying to understand it, I couldn't find an easy to digest explanation of how it all works. So I will summarize information from these papers, and the link to them will be in the description, to explain in detail, but in simple terms, how ChatGPT works, how it was built, and what was the leap in technology that allowed it to be so dangerously effective and so popular all of a sudden. So first, let's look at the name GPT, Generative Pre-trained Transformer. Now, that's a nice combination of words, but what do they mean? Generative AI basically means an algorithm that can create something, text, images, videos, code. But how is this possible? How can a machine create something? When we see all the stuff ChatGPT can do, we can easily be drawn to near sci-fi conclusions. Well, we're not there yet. We are still in our narrow AI phase, meaning an AI that still outperforms us, but only in specific tasks. Then we have general AI, and that's human level intelligence. Rather than focusing on one task, it simulates how a human would think. An AI that is arguably conscious. And we are getting really close to this form of AI. And then we have super AI. And that's basically every movie about AI ever made. An intelligence that is far superior to ours. And somehow, after spending 2 minutes on the internet, it decides, yeah, they need to go. But for the AI we have now, to be able to generate something, it needs to be trained through a language model. And that's the first thing you see when you look up the definition of ChatGPT. It is a large language model, or LLM. To understand what a language model is, let's look at this example, the weather model, also called forecast. Because that's what a model does. It tries to predict the next event based on past data. You feed it data like temperature, wind speed, etc., and it will predict the future weather. And the more data it has, the more accurate it becomes. A language model is the use of probabilistic algorithms, and the goal here is to predict the most likely next word in a sentence based on the previous entry. So its creation is mainly prediction. Now, the problem with language model compared to other models is that machines do not think like us. A normal conversation between you and I is incredibly challenging and complex for a computer to understand. It can understand temperature and wind speed, but understanding sarcasm is a whole other problem. So how was ChatGPT language model trained to be able not only understand us, but to answer in the most human-like manner and with near infinite knowledge? The answer is pre-training, which is the P in GPT. Through machine learning, which just means training a system to make predictions based on data. We have two main ways to train a language model: supervised and unsupervised training. There is more training involved in ChatGPT, and we will get to that later on. But to understand how ChatGPT was trained, we really need to understand these two training methods. First, supervised training. Supervised training models are meant to learn by example. The program is given an input linked to the desired output. For example, we will give the program a picture of a dog with the desired output, dog, and a picture of a cat with the desired output, cat. Now, these outputs are hard-coded and linked to the images. They are labeled data, and that's what supervised training is. It's training a model on labeled data. Now, we repeat the same process with labeled images for different dogs and cats of different breeds, sizes, etc. And then we give the program a picture of a wolf. Now, the program never saw a wolf before, but it will predict that it is a dog, because it is the closest thing to the two examples it was trained on. That's because the program will create patterns based on the labeled data it has. It doesn't only know the cats and dogs you show it. It will take the picture of the dog and it will deconstruct it. It will break it down into little pieces like nose, mouth, eyes, and it will try to make patterns. So if we show it a dog that it doesn't know, it will know that, okay, for a dog, it needs to have these characteristics to be categorized as dog. When you get a spam email, the process is exactly the same. There was a supervised learning program that was given bad emails and he was told they were bad. So they were labeled spam emails and then given normal emails and told they were normal. So by analyzing these emails, it creates links to what it is considered a spam, maybe a foreign language you never spoke before. The same mail may have been sent to a lot of people, maybe containing links to follow, shady emails. So that's how when a program sees a new email, even if it has never encountered said email in its training, it will know it's spam most of the time. Now, this approach has obvious limitation. A human needs to label a large quantity of inputs, but if we are talking about an AI that can do what ChatGPT does, it can talk about any subjects, it can train you for interviews, it can do so many things. It is simply impossible to train it only this way. So we need the second training method, which is unsupervised training. This approach is very different. The goal here is for the algorithm to find its own patterns in the data we give it. So to go back to our example, it's like giving it enough pictures of dogs and cats without labeling them, and on its own, the algorithm finds patterns and differences and is able to classify these animals without any human intervention. The drawback is that the model is less accurate and needs longer training time. So supervised learning refers to algorithms that learn patterns from labeled data, and unsupervised learning refers to algorithms that can learn patterns from unlabeled data. And for ChatGPT, it was a combination of supervised and unsupervised training, which is called semi-supervised training. So first, we feed it a lot of unlabeled data, which is the unsupervised way. We get a model that is decent with a lot of information and already made a lot of connections and patterns and sorted all the stuff we threw at it, but makes mistakes. And then we fine-tune it with labeled data, so it can make more accurate predictions. These learning methods are run through something called a neural network. A neural network is a group of algorithms. We are trying to make a computer learn by simulating the way a human brain works. It works through neurons that are called nodes and layers, groups of neurons forming layers. So we have an input layer, we have some hidden layers, it can be one or more, and then we have always an output layer. So we can think of the input layer as the eyes. That's where we give the algorithm information, the prompt, the input. The output, it's what's coming out. That's the answer you get from your prompt. Every input has a weight, and every neuron has a bias. They may increase or decrease the importance of an input. And this is the main difference between the GPT models. GPT-1, GPT-2, GPT-3, it's the number of parameters. The neural network gets larger and larger, more complex, more parameters. And the more complex it gets, the better the answers we are getting from it. So if we want to go back again to our example, let's say we want a machine that recognizes animals. So we show it a picture of an animal and we would like it to recognize the animal. So first we will show it in the input layer, the eyes, we will show it a picture of a dog. Then it goes through the hidden layers, which we can consider the brain. The signal is traveling between each and every neuron, thinking of what is the most correct answer we can give based on the knowledge, the data we have. And then the output, first at random, it will tell you, will show it a dog, it will tell you it's a giraffe, you will show it a cat, it will tell you it's a whale. And you can say, no, that's not the right answer. And it does the same thing, trying to get it right. And that's how it improves. So with enough data and inputs, it will create a system to learn from its mistakes and improve continuously. So for our examples of image recognition, These systems work great, but for languages, they really struggled. That's until 2017, from a paper called Attention is All You Need, that introduced the transformer model, which brings us to the transformer part of GPT. And all the buzz in the recent months about AI came from this transformer model. So, what is a transformer and why is it such a big deal for AI? To understand transformers, let's take a step back. Because before transformer models, we had recurrent neural networks, RNN. Now, RNN were only able to understand one word at a time. The best example of this would be translation. A few years ago, if we would like to take a sentence in French and we would like a translation in English, it will be most likely very literal. And that's a word by word translation. The problem with that is that sometimes it loses all meaning. So, for example, if you would like to translate "It's raining cats and dogs," it will literally translate it to "It's raining dogs and cats," because RNNs can only understand word by word. RNN models have a huge problem remembering past information. In this sentence, I like my cat named Snowball. What can I do with Snowball today? It might answer, throw it at your friend, because it lost the first information that Snowball is a cat. The longer the gap between relevant informations, the higher the risk of loss of information. And that's the main problem with RNNs. The probability of keeping the context from a word that is far away from the current word being processed decreases exponentially with the distance from it. The further we go, the less it remembers. RNN will process one word at a time. And for text generation, it only generates one word at a time. But languages don't work that way. You need context, ideas, an understanding of the whole sentence or even paragraph. Unlike RNNs, transformers process the entire input all at once. How can they do that? Mainly through self-attention, which was the big part of the 2017 paper Attention is All You Need. It is a technique used in neural network for paying attention to specific words. The self-attention mechanism allows the input to interact with each other and find out who they should pay more attention to. It uses attention to understand the relation between words. It has two components. We have an encoder and then we have a decoder. Through this model, a sequence or a sentence will be broken down in the encoder part and each word will be assigned a value. And then the decoder generates the output. That way, it has a good understanding of the relationship between words and the full meaning. So just like you and I may be reading a book and then we need to go back a few sentences because we feel like we missed the point. Self-attention works in the same way, where it will take the input as a whole and try to make a sense of it, rather than one separate word at a time. So now that OpenAI has this amazing model that can understand and process a huge amount of data, they needed to fine-tune it to be viable for public use. And they did this through something called reinforcement learning. So what's reinforcement learning? Basically, it's a machine learning training method. The goal here is for the machine to make decisions, using rewards when it does something useful and punishment when it does something wrong. Let's take a Pong game, which is one of my favorite examples in understanding reinforcement learning. The program has only two options, up or down, and the scoreboard acts as the reward system. So first, the program will try all sorts of random movements. Every time it loses a round, it knows it did something wrong and slightly changes its movement until it gets lucky and scores a point. And from there, it will slowly improve its decision making by fine-tuning its movement to be the most precise possible and filtering out all the useless movement until it becomes literally unbeatable by a human. So this is the cycle of reinforcement learning. We have the agent, which is the learner, which is our program, our model, and we have the environment. It's what the agent interact with. So in our case, it was the Pong game. And the same principle applies to more complex games like chess or Dota, or even decision making in self driving cars, for example. But of course, the reward system that need to be designed here is a lot more complex. Because there is no immediate reward like the game of Pong, for example. In games like chess, the only real measure is winning the game. So every action needs to be correlated to that distant goal in the future, which is winning the game. Now, how does reinforcement learning comes in when we're training ChatGPT? Well, OpenAI used a subcategory of reinforcement learning called reinforcement learning from human feedback, which was the final step of the process and the thing that made ChatGPT so unique. So, reinforcement learning from human feedback boils down to 3 steps. First, we need a language model that is already pre-trained. Luckily, we already have that. Through supervised training, we have now a model that can understand and correlate data that we throw at it. It even outputs coherent enough answers. But just because an answer is coherent doesn't make it useful. It might understand the information, but not what the user wants. Step 2 is we create a second model, a reward model that takes in whatever our main model outputs and will score it. So we have one machine judging another machine. So how do we train this judging machine? So its score will align with human intentions, because ultimately that's what we want. We want it to give a good score to outputs that are useful to us and a bad score to outputs that are useless. So this second reward model needs to be trained with a human touch. So we get a human involved, we ask our main model to output different results from a prompt we give it. Then we ask our human to rank these outputs from best to worst and feed both of these data to the reward model. Now, not only our reward model has the different outputs, but also a score from a human. Then it will automatically begin to predict the right answers based on human preferences, meaning mimicking what it thinks a human would find useful. And this gets dangerously close to a machine being able to manipulate us. So let me give you a quick example here. And we will follow along in the diagram so it's really easy to understand. So here is our model that we already pre-trained. We will prompt our language model. Let's say we will give it a question. Let's say, what's the use of a calculator? And we will ask it to give us a few answers. So it will give a few outputs. So maybe the first answer will be a calculator is something you sit on. Not wrong. The second output, the second answer will be a calculator is, and it will try to define what a calculator is, but that's not the question. We really told it what is the use of a calculator. Even if the answer is kind of right, it knows that we're talking about a calculator, but giving me the history of the calculator, the inventor of the calculator, is not what I want. And then a third output will be a calculator is used to perform calculations. So we give those different answers to our human. Now, obviously, a human would know that, yeah, we don't sit on a calculator. Yeah, we don't really need to know the history of a calculator. The third answer is what a user would want. So the human will score it higher. And then it will give the outputs that are now ranked to the reward model, the model that is supposed to improve our main model. So the reward model has all the outputs, but it also has the scores. And it will tell our main model, okay, this is what a human would find useful. You and I are just machines, and yeah, technically all our answers are right, but for a human, it prefers this, then this. So the LLM will learn, and then the next time you ask it, what is the use of a calculator, it will give you what a human would want to hear. And the third and final step is further fine-tuning using a specific algorithm called Proximal Policy Optimization, PPO, also developed by OpenAI in 2017. The goal here is to get a balance between performance and comprehension by improving the agent learning stability. PPO is useful in that a policy will not blindly keep improving. It will keep checking that is not too different from the old policy and only improving what works. So the PPO system rewards the model when it improves but punish it when it changes the policy too much. So it's a controlled improvement. And that's basically how ChatGPT was trained and is able to take a prompt from us and deliver an answer that is close and sometimes impossible to distinguish from a human answer through layers and layers of machine learning algorithms. This is really exciting, and we are just scratching the surface of what AI can do. Thank you for watching, and I will see you in the next one.